Hey everyone, I wanted to take a quick second and just review what we learned about the graphs of log functions. My classes did that like the very last day before school closed down, and there is a question on the quiz about that. So I just wanted to make sure that we reviewed it before you hit that material. So let's suppose that I want to graph this thing, y equals log base 2 of x. Just so you know, your calculator probably won't let you graph that because your calculator really only focuses on log base 10, okay? But we're going to learn a workaround here where your calculator will do it for you. So because I like exponential form better than log form, it just makes more sense to me. I'm going to take this thing and rewrite it in exponential form. And so remember, that would be like 2 to the power of y equals x. That's this thing here. Okay, so these two things are equivalent to each other. Here where I drew that arrow, these two things are equal. So if I want to make a table of values for this function, I know this is opposite of how we usually do things, but there's a reason that this is happening. I'm going to actually pick numbers to plug in for y instead of picking numbers to plug in for x. So I might go 0, 1, 2, 3. I'm also going to throw some negatives ones in there. So I'm going to go -1, -2. And just because I have another line, we'll go -3. Okay? So what I'm doing is 2 to the power of this y number, and that's giving me my x value. So 2 to the power of 0 gives me 1. 2 to the power of 1 gives me 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Now think about this one. 2 to the power of -1. Remember that negative exponents flip things over. They make them reciprocals. So 2 to the power of -1 is 1/2. 2 to the power of -2 is the reciprocal of this guy. It would be 1/4. And 2 to the power of -3 would be 1/8. Okay? So when I go to graph those coordinates, I'm going to go 1, 0, which is here, 2, 1. You see this down here? Sorry. Set that up for you. 4, 2, 8, 3. Let's see, did I even go out to 8? Oh, just barely. Okay. And so what I see people do a lot is they'll graph that much of it and they'll kind of draw this curve in and then they'll leave it. But you're leaving off like a really, really important part of the graph if you don't get those negative numbers in there. That's why I had us make sure we put these in there. Okay? Because 2 to the power of -1, which is here, is 1/2. So there should be a dot at -1, or sorry, 1/2, -1. 1/4, -2, and 1/8, -3. And what I'm hoping you'll kind of see is that I can keep going like further down this negative line, and these fractions are going to keep shrinking and shrinking and shrinking, but they're never going to turn negative. Okay, they're never going to go past 0. And so that means that this line is going to keep getting closer and closer and closer to the y-axis, but it's never actually going to touch it. And we have a word for that, okay? That this thing is going to skim right along that y-axis but never actually touch it. This is y equals log base 2 of x. Now, this whole thing that I did up here where I flip back and forth between log form and exponential form, there's a really important reason that I had you do that. Let's suppose I then said to you, find me the inverse of this function. Okay? If you were to find the inverse, we would switch the x and the y, right? So we would make this x equals log base 2 of y. But we like to rewrite our inverses so that y is by itself. So watch this. If I take this and I flip it to exponential form, just like we did above, we end up with 2 to the power of x equals y. And then I have my y by itself like I like. Okay? This thing right here is an exponential function. This is what we learned about at the beginning of the chapter. Okay, we learned what y equals 2 to the power of x would look like, and your calculator will graph this one for you. Okay. Okay, so what you can do is you can graph this on your calculator what's going to end up happening is you're going to get this same table of values, but your x's and y's will be flipped around. But then you can just switch them if you want to make a graph like this one down here. So you can get these values out of your calculator by graphing this function and then flipping the x's and y's, because these two things are inverses of each other. Okay, so really you've got like 4 different versions of these functions here. The blue ones are equivalent and the pink ones are equivalent. The ones I would make sure you know the best, though, are these two. So y equals log base 2 of x and y equals 2 to the power of x. Those are the 2 functions we want to focus on because they're written in terms of y. Okay, so these 2 are inverses of each other. Okay, so if I were to graph this thing, y equals 2 to the power of x, basically it's all of these points here reversed. So I would have the point 0, 1. I would have the point 1, 2. I would have the point 2, 4, 3, 8. I think it's about there. I would have negative 1, 1/2, negative 2, 1/4, and negative 3, 1/8. So you see that same kind of thing happening here that was happening down here a minute ago. The exponential function looks something like this. By the way, you've probably been seeing a lot of these exponential functions in the news lately, so it was pretty nice to at least see some relevance there, right? So here's an exponential function. This is the function y equals 2 to the power of x. This is the function y equals log base 2 of x. And notice that these 2 are reflections of each other over that diagonal line because they're inverses of one another. Okay, let's talk about all of our favorite things. Domain, range, asymptotes of each of these functions. Okay, and then same thing for the pink one. And actually, I'll start with the pink one because we got really good at this right before we left school. So we were talking about exponential functions, and we learned the domain and range, and we learned that they never change. They're always exactly the same. So the domain is everything left to right, right? Because that pink graph goes forever in both directions. So my domain is all real numbers. My range, because this always stays on the top half of the graph, is all real positive numbers. And then you will notice we have an asymptote here on the x-axis. Okay. So my asymptote is the x-axis, otherwise known as y equals 0. Okay. If I'm looking at the blue graph, because these 2 things are inverses of each other, my domain and range are going to flip-flop. So this time my domain, notice this all stays to the right side of the graph. My domain is all real positive numbers. By the way, this is why you were finding that you were getting no solution when you try to do a log of a negative number. You can't take the log of a negative. Notice that this function doesn't exist on this half of the graph. The range, this goes up and down, so my range is all reals. And again, this is just flip-flop from this one. And this time my asymptote is the y-axis. Okay? Again, flip-flop from what it was before. So asymptote is y-axis, otherwise known as x equals 0. And I do just want to throw in one more thing here. Let me see if I can find a different color. One other thing you should know is where the intercepts are. You'll notice that the pink graph has a y-intercept right here at the coordinate 0, 1. Okay? And it has no x-intercept because the x-axis is an asymptote. This graph always contains the point 1, 0. It has an x-intercept, but it has no y-intercept because this line is an asymptote. Okay? So this is an x-intercept, and there is no y-intercept. This is a y-intercept with no x-intercept. Okay? Okay, hopefully that was helpful. Hopefully that kind of got you going in the right direction as far as graphing these things. Again, if I asked you to like type a graph into your calculator and look at it, if you can't type this in directly, I would type the inverse in and then just make sure you take the x and y values and flip-flop them, okay? The one thing you want to watch out for on your calculator is your calculator tends to show this only in this top half. It's really, really hard to see this line extending down here. You need to make sure that you know that that line does actually extend. Okay, I hope that was helpful. Please let me know if you have any questions.